Gumrock Creek.
Right now we're going to build all the wires and get them ready to run them down to the electrical cabinet from the solar panels. So I've measured out kind of how long they each have to be. I have a bunch of really long pre-made of the right gauge. However, they're longer than I need, and I have less pre-made ones than I need, so I'm going to have to cut and put some ends on. But I have the kit from VE.Direct to do all of that stuff and put the ends on, so that shouldn't be a problem. So I'm going to prep all that down here, get it all ready, and then we'll haul them up. I already drilled all the holes and put all the conduit in and everything to get the wires from the panels through the roof, flashing and down into the cabinet. So let's build all these wires up, and then we'll go see if we can get them hooked up. So these are like 200 feet of wire, 12 gauge, and then you can see it on each end. It already has the ends on it. However, I don't need it that long. I'll have to cut it down. So we'll put the other end on wherever we cut off. Actually, what I'm going to do is I'm going to cut these off at the right length and not put the ends on them. That'll make them easier to feed down through the conduit. And then once they're in the cabinet, I'll put the ends on then. So let's get these cut to length. Well, that works out perfect from the deck right to the trailer tongues, right about the right length. So I'm cutting these right about 38 feet, which should be several feet longer than I need. I'd rather have too much on the end and cut it off than be short and then run out of wire because they're all too short. So let's cut them up. So these VE.Direct solar ends are super easy to put on. You just use a standard wire trimmer, trim off the tip. Use the crimper that comes with their tool set to crank this little guy on. And then these two blue tools, just crank it down, crank down the end on. So pretty straightforward. That was a bunch of work. We got all the wires pulled for all the panels. So again, we have 10 panels up here. They are in pairs. So each pair is in serial. So 2 panels in serial, 5 sets, and then they all go into parallel when they get down to the electrical cabinet inside the PV combiner box. We did get all the wires run and up through our little PVC pipe through the flashing. Right now I pulled the ground wire up through here. I'm going to run it, and as you saw in the previous video, I need to connect it to each rail all the way across to ground all of these rails, and then we're done on the roof, and we'll go down and start moving stuff into the electrical cabinet. Grounding wires in between all the rails down into the electrical cabinet. So now we'll go down there. Back at the cabinet now, you can see up on top there where all the wires came through from the pipe we just fed them down from the roof. So fortunately I labeled them all before they came down, so I do know what all of them are. So now I'm going to mount the PV combiner box. If you watched the earlier videos where I went through all of the equipment, I went through this little box, but basically this will take all of these pairs of wires and feed them in parallel. So that will come into this box, combine into a parallel feed, which will go to the solar controlling charger. So let's get this mounted, terminate all these wires, and then we can check for the PV open voltage, make sure all the panels are doing what we think they're supposed to do. I measured a couple of them just raw off the roof before I started today, and they were right where they should be. So I don't know how much you're going to be able to see during all this because I'll put you inside the cabinet. You can hang out in the corner and watch. The PV combiner box has the normal ends, solar ends on them. So some of these wires are bare ended, so we'll put the right pieces on when once we get ready to connect them. So you can see got the first four in. These are the upper and lower left side panels. So 2 more on here and 2 more in here.
Okay, I went over to see.
Okay, got them all terminated. Ends on, connected to the PV combiner. I did pop all the fuses out here before I did that so that none of them are combined in parallel till I'm ready. What I want to do now is test the open voltage across all of them and make sure the 2 in series come out to around the 93 volts for open voltage for those panels. And then once I know they're all accurate, then I can push the fuses back in and bring them all in parallel. That way, if one pair of them is messed up or has a low voltage, I don't cause problems with the other ones by putting them all in parallel all of a sudden. So check them first, then push them together, and then we're ready to go. Okay, what we should expect to see is 91, 92 volts somewhere in there on each one. There we go, 91.6, 91.2, 91.6, 91.2. Marvelous. So now we can push these closed. That puts them all in parallel now. So we have 2 panels in series, 4 sets of those, and those 4 are in parallel. There is a 5th pair that is in series. However, this combiner is only good to 4. So we have a small controller that we're going to connect those other 2 on their own and put them into the system. So the beauty is that each of those, as you saw in the series sets, are 91.6 volts-ish, 91.2, which is their open voltage for those panels. Once we lock those in parallel, because they're in parallel, the voltage should stay the same. So we should still see 91.6-ish across this whole PV combiner. So let's test that. There you go. So now we can wire this box, the PV combiner, into this solar charge controller. We do have some heavy 8-gauge wire for that. So let's go get the equipment out of the storage container and move it over here, and we'll start hooking that up. So we have 10 panels. Originally what I was going to do was 4 in series and 3 in parallel, 3 sets in parallel. However, I realized when you do that, I had redone the math at some point. So the voltage that way was it was over 200 volts, which the charge controller I have is not quite that big. So I could have bought another one, but then I realized, well, the PV combiner would do it. It goes up to 250. I was like, well, that other charge controller is expensive, and I already have one, so that's a waste of money. So what I do have is another little charge controller that's was going to be used for the storage container. I already have it. So what I'm going to do is I'm going to take the 8 panels we have, which is 2 in series, and then those are in parallel. So those 8 panels will add up to roughly 92 volts. And I think they'll be around 40 to 50 amps that way. And they'll go into the controller we have through the PV combiner. That other set of panels, those 2 panels, what I'm going to do is just run those directly into this small charge controller on their own and feed them into the system. The really cool thing is, because it's all Victron and I have the smart system that connects it all together, those controllers will talk to each other and they'll make sure that one's not charging more than the other, and they work together to make sure everything's all balanced. So that's a super cool feature. So I'm not too worried about that. And then at some point we'll add the wind controllers into that as well. So that's how we're going to wire it for now. And then if we add more panels later, we'll probably have to get another combiner and do something different there. But we'll see how this goes for the winter. And hopefully we have enough power anyways, it won't matter. Pulled some of the gear out of the storage container where it was. If you want to see what all that gear is and what we're using, there's a video, probably first one or second one in the series on solar, and you can check that out to get more details on them. When the whole thing's complete, I'll probably do a walkthrough as a separate video, but for now, pull a lot of that out. Gonna start mounting it in here. The minimum, I want to be able to get the batteries hooked up so they're charging, and then the inverter, and then we'll start working on all the rest of it, the DC converters and the fuse panels and all that good stuff. PV positive, right? All right, plugging right along. Main charge controller, the small charge controller that I talked about for the other two panels. PV combiner, that's all wired, so panels are all in. PV combiner, wired solar charger. Just put the fuse panel in so I could start putting the grounding wires in, because I have a grounding rod we'll put out here, which will ground to this box, which then grounds the lightning arrest for the PV combiner and also grounds all the solar panels, and then all the equipment in here will have grounds on it. So all right, time to load all of those in the back of the truck, get them up to the property so we can get them all hooked up and connected to the solar panels. So 100 and I don't remember, 60 pounds each or something, I don't know. We'll start moving them and see how it goes. Pulled all the cables off the batteries that we had jumpered there to keep the chargers on them, and then I went through, took all the bolts out of where the connections go, and I put them in a little baggie and put them in the truck. But then I covered all of the leads here where the bolts go in with some tape, just to prevent anything from accidentally shorting them out while we're trying to move them and install them. That way they are all kind of safe and secure, and hopefully we'll get up there no problem. So let's start moving them. Ah, got them all in there. All right, we got a whole bunch wired today. The system is actually online. So what we did was as I mentioned earlier, we got the charge controller running, PV combiner coming off the panels. We have the extra MPPT up there that will run the two additional panels that I talked about. I have not wired that into the batteries yet. That's still on the list. However, the big boy is hooked up, goes down through the fuse, switched, all the way to the power to the batteries. Did get the inverter wired. It's got a fuse. I did not put an external switch on it because it has one built into it, so it can be switched off separately. I did not wire the inverter to the breaker panel yet, but I did, however, plug the Starlink directly into it. Starlink came right up. We remounted the dish up on the roof earlier today, so Starlink's back up and running. And then what I'll want to do is wire the inverter into the fuse panel, or sorry, into the breaker panel, and then we can start wiring the building from there. Things not done. This is the 24 to 12 volt DC converter. Since the system is 24 volt, we're going to be running some 12 volt things inside the building, and I'm not going to go to AC and then back to DC. I'll just leave them in DC. So this will convert the 24 down to 12. This right here is a little device that monitors the DC feeds, and if the battery banks are getting low for some reason, the Victron system will tell this device and it will shut the DC loads off automatically. Also allows me to remote shut off the DC loads from the web or from my phone. So that's kind of a cool little thing I picked up. I didn't know they made it until I found it the other day. I was like, oh, I should get one of those, because it's often those DC loads that you aren't paying attention to and they drain everything. And then up here is the charger for generators. So it's not wired in yet. I'll wire this AC port out to a port on the building, and then we'll be able to plug a generator in, and this box here will charge all of the batteries in addition to or instead of solar. So I will run a switch right here so I can switch that off. So I could turn the solar off, turn that on, vice versa. And then lastly, they're not in here yet, but the wind turbine controllers will go right up there on the top. So it's coming along pretty good. The other thing not done is I have this battery balancer down here from Victron, which helps balance batteries that are in parallel and keep them all like charging correctly, and it changes how the system charges based on what it reads. So that's got to be wired in. It takes a few little wires to each battery, so I will get to that, but we're getting close. But right now it's up and running. We can run AC loads if we need to, and we can start wiring the inside of the building because we can come straight into the breaker panel now. So for the AC side, the DC side, we'll start dragging the wires in and dropping them off here until I can get the fuse panel in for that. So awesome. It's been exciting waiting for this to get to this point. So one of the other things I forgot to mention was DC shunt. So Victron makes a DC shunt that you put right before the battery. The battery feeds here, and then this feeds the rest of the negative bus. That shunt though connects to the Victron remote system, so it will have a cable from it to the controller, and I can get really good amperage readings and control things from this shunt. So that's pretty cool. Excited to see that work. So finished up for the weekend. This weekend we got a bunch more stuff wired. We did get both MPPTs online, so they were both charging and talking to each other to manage the batteries. We did get part of the 24 to 12 volt DC converter I talked about wired. Still have to get in the fuses and stuff. That's not done. Obviously the charger for the generator is not important right now, but we will get to that eventually. Did get the inverter hooked up, started on the breaker panel. We did get one outlet in just to make sure it all worked, and got it all tested. That outlet is now running the Starlink, so Dishy's up and happy, internet's good. I did get the Servo GX installed, which is the brains of the whole thing, and I got it wired to most of the devices. I'm missing a cable or two for like the shunt, so I'll have to pick one of those up, but everything's wired. It connected right to the Wi-Fi and went out Starlink, and I can get to it from the internet, which is awesome. I also can get to it from my phone here on site with Bluetooth. And then I did install the cool little panel here. See if you can see that. There you go. Which eventually could go in the house, but right now it's just sitting here. But lets me go in and pretty much see any device, all the data about it, and then as well as a visual of the charging system and what's happening at any time. So that's pretty cool. We'll mount that later, but I wanted to hook it up right now and make sure it worked. So yeah, a few more little odds and ends to do inside here, and some stuff on the DC side. Get a few more parts for the AC panel. So next time we're up, we can really start pulling the wiring through the building back to here, DC and AC. We'll use DC to run all the USB ports and some of the lighting, and AC for everything else. Everything's up and running. Batteries are here. Everything's charging. Watched it overnight as the sun went down. Voltages came down as I expected. Dishy ran off the batteries all night long, and then this morning it charged everything back up. So seems to be working great. We'll see how it goes. But next time we'll poke at this some more and really start working on the inside of the building.